Okay, for our first example, we have in one Florida election, 47% of all registered voters actually voted. A researcher studying the behavior of academics was curious about whether political scientists voted in the same proportion as the rest of the people in the state. To answer this, the researcher took a random sample, I'm going to go ahead and underline that, without replacement of 54 political scientists who live in Florida, and he interviewed them to determine whether they voted in this election. As it turned out, 40 of the 54 political sciences in this sample voted, which is a sample proportion of 0.74. So I'm going to label a few things here. What's important, one important thing to note here is that this is the sample proportion, so this is our p hat. What actually happened in the sample was 0.74. This right here is our p. What's happening overall. Okay, we want to carry out a 4-step hypothesis test to determine whether the proportion, this is what we're determining, whether the proportion of all political scientists who voted in this election differed from the proportion of the general public. Okay, so the first thing we have to do is we have to write our hypotheses. We have to write our null and our alternative. So again, the null is always that P equals something. And it's that P equals the accepted value, like the boring value. So here, it would be that P equals 0.47, right? That there's nothing interesting at all going on with the political scientists, that they vote just like everybody else does. And then our our alternative is still about P, and it still has the same number over here, the same proportion over here, and we just have to decide which symbol to use. Are we going to use greater than, less than, or not equal to? And this is going to always be determined from the wording in your question. So when I read this last underlined portion again, we're determining whether the proportion of all political scientists who voted in this election differed from the proportion of the general public. So this political science, or this researcher does not care whether it's higher or lower. He's only concerned about whether it's different. So we're going to use the not equal to there. You have to get the right symbol there. Otherwise, your entire hypothesis test will come out wrong. Your numbers will come out wrong in the end, because that symbol determines which kind of a test you're running, a one-sided or a two-sided. They did not give us a significance level to use here as I go to step 2. So I'm going to use the default 0.05 in that case. The test statistic that we're going to use here is Z. And the reason why we use this isn't a problem yet, but it could be later in the semester, is because this is a proportion or a percent type problem. What we're looking for here are percentages. We've got 47% or not. Everything is a percent. When you see percents, the test statistic you're going to end up using is the Z. And now we need to check those 4 conditions. This ends up being the hardest part of running a hypothesis test, and it's the longest part, is checking these conditions. So let's see. The first is, do we have a random sample? And yes, I underlined that keyword up here so I can check that off. 2 is, do we have a large sample, a large enough sample? So he interviewed 54 political scientists. Was that enough? So let's see. He interviewed 54 of them, and the p-value, if we look up a little higher, the p-value was 0.47. So he has to have interviewed enough people to expect at least 10 of them to have voted and 10 of them not to have voted. So let's check those. Does NP come out greater than or equal to 10? And does N1 minus P come out greater than or equal to 10? That's what we're checking. So is 0.54 times 0.4, sorry, not 0.54, just 54. I need to get rid of that decimal point. I'm going to just cross it out because my eraser really hates me and it makes my keypad come up for whatever reason. Okay, so is this greater than or equal to 10? It's actually 25, so that works. And is 54 times 1 minus 0.47 greater than or equal to 10? Well, that's 54 times 0.53, which comes out as 29. So that's greater than or equal to 10. So he would have expected 25 people to say yes and 29 people to say no. So bigger than 10 each, so we're good there. The third is the population big enough? Is it at least 10 times the sample? Well, the sample was 54, so 540. Where was the sample taken from? What was the population it was taken from? It looks to me like the population where he chose these people from was they had to be political scientists in Florida. So do you think there are more than 540 political scientists in Florida? I would imagine so. And then the last condition we have to check are, should these be independent from each other? And again, I would say yes to this one. Why? Because not like one person's answer shouldn't affect another person's answer. If it was a truly random sample, then these weren't all political scientists from the same school or from the same area. So they should not be affecting each other in any way. So because all of those check, basically that lets us go ahead and use StatCrunch in the way that we're told to use it to finish this problem. If those things don't check, nothing keeps you from running the test, but you cannot trust the results you get. So that's a really, really important step. Okay, so now that we're good, we're going to use StatCrunch to calculate the 1 proportion z statistic and the p-value. The two pieces of information you need in StatCrunch to run this is you need the number of successes that were observed and the number of observations. Those are the two pieces of information StatCrunch is going to ask us for when we flip over to it. So the number of observations were the 54 political scientists who were asked. And a success would be that they voted in this case. So here all we know, or all it has told us, is that 74% of them voted. So you're going to need to do a quick calculation here. How many is that? How many was 74% of the 54 who were asked? And it should come out as 40.